Okay, in the last video we discussed arcs and central angles. Today we will focus our studies on inscribed angles. I'll begin by introducing some new terminology, theorems, and corollaries. Along the way, I will complete some examples that will demonstrate how to apply this new information. This is the first video in a series of two, so let's get started. Inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So if we look, we have angle BAC, and we're told that that intercepts arc BC. And that term's going to come up quite a bit, so make sure that you understand what that means. And let me show you what I mean by this. All right, so if we look at angle BAC, and I'm going to highlight that in yellow. Okay, it's an inscribed angle because its vertex is on the circle, as we can clearly see. And the sides, so AB is a chord of the circle, and AC is also a chord of the circle. Now, that angle is said to intercept arc BC. Okay. And then let me grab a different color highlighter real quick. If we look at angle BAD, and I'm going to kind of overlap this, so BAD is also an inscribed angle because, again, its vertex is on the circle. And then the intercepted arc in this case would be arc BCD. Okay, so BAD is in blue, and then BCD is the intercepted arc. Okay, so that's the new terminology that you need to know for now. The theorem that we're going to take a look at in this video says that the measure of an inscribed angle is equal to half the measure of its intercepted arc. So if you look in the diagram on the right, it says if angle XYZ, which I'm highlighting in blue, is inscribed in circle A, then that angle is half the measure of this intercepted arc. Okay. Now, what I'm going to do is walk you through a couple of examples that demonstrate this theorem. So let's go ahead and look at examples 1 and 2. Again, that will illustrate how to apply that theorem. All right, so for example 1, we're asked to find the values of x, y, and z. So I'm going to determine the value of x first. So if we look at x, okay, x is an inscribed angle, and the arc that it intercepts is 80 degrees. So according to the last theorem, or the theorem that we just looked at, x should equal half the measure of that intercepted arc. So half of 80 degrees is 40 degrees. So x in this case is going to equal 40 degrees. Now let's move on and take a look at y, or how to determine the value of y. So the angle that intercepts arc y is 55 degrees. So this angle is half the measure of this arc. So that means in order to find y, we're going to have to double 55. So the measure of y, arc y, is going to be 110 degrees. And I'm going to actually label that on the diagram because that's going to be helpful in finding the measure of arc z. Okay, so for arc z, if you look, pretty much all the other arcs, or the measures of the other arcs that are given to us in the circle, we can see here. So if you look, all those arcs pretty much complete a circle except for this remaining piece here, which is the measure of arc z. So all I'm going to do here to find the measure of arc z, I guess we'll keep the yellow, is we're going to add up 110, 90, and 80, and then subtract that from 360. So that should give us z equaling 80 degrees. All right, let's take a look at example 2. So again, here we need to find the values of x and y. So I'm going to find x first. So again, x is an inscribed angle. Its vertex is on the circle. And the intercepted arc is 40 degrees. So x is going to have to be half of that. So x is going to equal 20 degrees. To find y, it's going to be a little bit tricky. I'm actually getting a different color than blue. Go with yellow here. So if we look here, we got angle PSR, which intercepts this arc right here. So that arc has to be double of what 50 is, which is 100. So 100 degrees. And y is going to be whatever 100 minus 40 is equal to, because you've got 40 degrees here, and the rest of the arc has to sum to 100. So we're going to subtract 40 from that, and we're going to end up with y is equal to 60 degrees, even though that doesn't look to proper scale. Based off of the measurements that were given, that is correct. Okay, so this is the first video. I'm going to stop this here. In the next video, we're going to look at some corollaries to this theorem, and also a new theorem, and go through a few more examples. I hope this was helpful, and we will see you in the next one.